card, based on the password, based on the biometric. But if I do not define any kind of mechanisms where if the smart card is lost, if the smart card is stolen, then I cannot block that smart card and revoke the new one. It is useless. So that's why the mechanisms must ask to us to design a mechanisms where the smart card revocations is being done. So where we can easily block any of the existing smart card and we can select the new smart card as well. Where most of the servers or most of the services provides. So these are the
yeah.
Okay, now I must extend my thanks to Kunal. He just joined and he just not only that, there is one thing I must mention. He just boosted the R&D activity of our department. So I just no. So there is a Dr. Kunal Das. He just like to he should talk on that. Already to make it Oh.
Respected Professor Yulia, respected Dr. and respected all our colleagues and my dear students. It is very pleasant to represent my research topic. Is actually I just started this research topic in 2014, and before starting this research topic, I must say that today what we are discussing, that is basically the dream of our Prime Minister Narendra Modi. He proposed a digital India, and to be the digital India successful, we require the security that the Professor Bibia already discussed in cryptography, and last was the SB also discussing that how the traits we have to be a digital India successful. Now, my topic is quite different, that we also try to do the digital lab on chip or biochip. Why we are thinking that? Because if you think that in India, around 70% is a remote area. So in a remote area, there is maybe medical facilities is very less. And to taking the all medical instruments to the different rural areas is really impossible. So what about the healthcare? So if you go for their healthcare, then we must produce some chip or device that like this. So if it is a one device for testing multiple requirements of our healthcare, so that will be really easy to carry and test all the rural peoples. So that's why this target is a digital microfluidic biochip. So what is this actually? That is the main idea. Integrating all laboratory processes. Whatever we do in the laboratory process, if I collect a blood, that to be taken into lab, and in lab we require a big setup, and we will perform the multiple number of tasks in a lab, and we will finally generate the report. But if you do in a single chip, then what happens? And the chip size will be like a 1 rupee. The chip size is basically should be a 1 rupee. And we will integrate all these laboratory processes into chip. So the thing is it's basically VLSI. And thing is looking what in traditional we know that electron flow in a circuit. Right? It's our known idea. So electron flows in a circuit, that is opposite direction currents. that is our idea. That was in our concept, that we know how the computer answers it. But in a lab on chip or biochip, electron through flow to control the microfluidic flow. So microfluidic is basically the main target to flow into the circuit to give you the result or analysis. So that is not really very new. If you go that in the microfluidic part, you will find that the continuous flow biochip is already available for only glucose testing purpose. Blood sugar as well. That is available by Acosure or other brands. That is the continuous flow biochip, and its lifetime is limited. First thing is that its lifetime is limited. You have to watch
That chip that we are using. Oh.
that is use and throw chip,
Yeah.
and its lifetime is limited because fluid flows continuously into your circuit. Now, our target is to make it digital microfluidic. What are the different possibilities? We can analyze a DNA array, protein array, even that is the different healthcare problems as I told you. Not only the concentrating only on the glucose testing, we can concentrate on for different disease analysis. That is basically the circuit is continuous flow, where basically you have a pump, and from the pump you take these reagents, and the reagents flow into the circuit. Okay, and that is generating the result over here. But in a digital microfluidic, that are coming into the, it look like a cell, and droplets or your microfluidic droplets, simple water droplet, that droplets do not flow into the circuit continuously. When it is required, then it flows. Otherwise, it remains stopped. What is the basic concept? The concept comes from very well-known idea, that is lotus leaf. We know that the lotus leaf is basically due to microfluidic surface of lotus leaf. Any water droplet will create this type of microfluidic nature. And we know that in a lotus leaf, it moves due to surface tension. That is the basic physics behind that, and that is implemented in your technology or in your chip. What we do, we actually do that. This is your water droplet, say, and we put is a ground, that is a low potential we have given, and here we have a discrete electrodes. This is a white shows that discreteness. So once we put this is the positive and this is the ground, so that is the thrust towards, if it is the left, then it is the right, so towards the thrust is towards the right. So what happened? The droplets becoming this way, they moving. What is the shape? I just write it. So initially it was a after the thrust, so what actually I want to say that this is this, and this is moving these, and this is moving this. So this is the propagation that took place. And that actually shown in a structure of digital microfluidic biochip, where we have given a top glass and we have a bottom glass, and these are the droplets. Okay. This is the one scenario, we actually putting the glass over here and droplet is moving into your circuit. Right?
No, but basically this is where what we are doing for different cases we are trying to get it from droplet, the different symptoms.
That is actually, this is a discrete one and this is the continuous one.
Yeah.
And it is connected to the ground. And now with the discrete, you putting the positive signal over here and then droplet will move it.
Okay. Okay.
And again, droplet is moving. Again, droplet is moving. So what we need to do? We need to generate a one control valve to move one direction to another direction. Okay. Yes, this is the actually invented by Duke University. This is known as a rotary mixture. I have this video, but I'm not. It will not come over here because I just take a snapshot actually. So what happened is a rotary cell, or you can say the rotary mixer, where the multiple droplets are coming out and it's mixed together. And in India, what is progress? In India, I visit the IIT Kharagpur. Professor Suman Bhattacharya is doing this research in the mechanical department. He also in 2013 probably he got for Battalion Power 13 or 14. Actually, he is also our ex-faculty member of our PPIT. That's right. So he is doing this work, and my PhD student actually now he's not my student. Actually, she was my MTech student. He is doing this PhD now in Kharagpur in this way. Now, what we can do? We can do the research work, the dispensing, navigation, how this navigate into the circuit. This bold part we actually worked. The mixing, splitting, obviously mixing and splitting both are equal. Sample preparation, reaction, heating, sensing, and waste reduction. If you go that, why mixing is different? Because we want to create all laboratory processes into our chip, into a chip. So when two reagents are coming, we have to require a mixing, and maybe two non-reacting agents are coming, then we require to produce dilution. So for example, if you have a 100% HCl in your test tube, if you want to create the 33% of the dilution, so what do you do? So we will take the water in another test tube and mix these two to create the 33% HCl. So if you do in the lab process, that also waste actually is coming. But how it's wasting? Because if you take the 1 cc of HCl of 100%, and if you take rest of the amount of the water, and you will basically generate 100 cc HCl concentration of 33%. So then, suppose you require only one droplet, that is a 1 cc you require. So your target was to generate a 1 cc HCl of 33%. If I consider 1 cc is the one droplet, that means you are wasting 99 droplets. That is really not useful for your reaction purpose. That also we will take care when we are doing a mixing and basically sample preparing. And this is a mixing process. When dilution is mixed, that can be in a 1:1 or 1:1 mixing process, or maybe into K into K, that is called balanced mixing. The two droplets are coming with a different droplet. Let's consider this is the water. Water is a 0% concentration of HCl, and this is a 100% concentration of HCl, suppose coming. Now these two droplets mixed, it creates the two volumes. And once this split, the question is how we can mix it and split it. Just put the one in a mixer and then let both droplet to come, and again put the far end apart, so they will split it. So two droplets will be generated, and these two droplets have equal concentration of HCl, that is 50% concentration is generated. For the time being, let's consider we want 25% concentration of HCl. So repeat this with another water droplet. Remove this one, and put another water droplet, and again mix it. You will get the 25% concentration of HCl. And these are the all unbalanced, everything are there. This is also possible. This is the example that we are talking about. This is the 70% acid, water, or all those things. This is the mixing strategies. We are talking about that. If we have this, if we have this is 100%, this is the water, and you are getting the 50%. Again, you do this. This is the 50% water, 50% HCl you actually wasted. Now you use the water, and then you definitely get the 25% HCl over here. So that is the how the algorithm or computer science can do the work. Computer science can do the algorithm development. How this can be minimized, because when we are doing the mixing process or sample preparation process, we need to minimize three things. One is the number of steps, what you are doing, number of samples, because samples is very costly one. Third, water is available, distilled water is available, or no water is available. So till still, how many number of buffer is called basically water, and waste. So 4 parameters is very important to develop, because unless we develop the algorithm, we can develop it in your hand.